Right? Isn't that 10? What do you raise 10 to get 10? Raise it to 1. So it's 6 minus 5 is 1. There we go. Right? Big M is 1. I hope, right? Let's hit the right arrow, make sure I haven't buggered something up, right? There it is, yeah? Woo! Okay, now this makes sense. Let's see why this makes sense. Aren't we, if we were 10 parsecs from that star, it would appear this bright, yes? But if we're 100 parsecs from it, aren't we 10 times as far? And by this formula here, wouldn't we receive 1/100th the light? Because we would, right, because it's d squared. If you're 10 times as far away, you receive 1/100th the light because it's inverse square, correct? And if you divide by a factor of 100, you go up by 5, and it's really a 6, yeah? So at 100 parsecs, it looks like a 6. At 10 parsecs, it looks like a 1, and that's what absolute magnitude is, right? So it all works. This is a good thing, right? Okay. The sun has an apparent magnitude of minus 26.8, so let's try this. That is the apparent magnitude at a distance of 10 parsecs. So basically this formula just corrects for any other distance, right? Okay. So the sun has an apparent magnitude of minus 26.8, right? So that's our little m. Right? Our distance is 1.5 E8 meters, right? Or we are about 4.9 times 10 to the minus 6 parsecs from the sun. If you ever wonder, right? 4.9 microparsecs from the sun. There we go, right? There's a unit not suited for that, right? What's the sun's absolute magnitude? Well, again, m is just going to be little m minus 5 log d over 10, right? So I just changed this guy around just like we just did, okay? And then, is that right? Yeah. So it's going to be m is minus 26.8 minus 5 log. And then our distance is 4.9 e minus 6 divided by 10. Yeah? This is going to be, by the way, a really small number. It's going to be 4.9 times 10 to the minus 7th. And to raise, what you raise 10 to is going to be, well, kind of a big negative number, right? Yeah? And then this is going to be 5 times that. So let's just see what it is. Minus 26.8 minus 5 log 4.9 e minus 6 divided by 10. 4.7. Is that what we get? Yeah. That's interesting. So it wouldn't actually be all that bright a star. It's on its way to being not visible. If we were 10 parsecs from our own star, it would just be another star, sort of an averagey, sort of not so bright star. Yeah. Magnitude 6, it's beyond our ability to see it, right? If you were in the city, you probably wouldn't see the sun if you're 10 parsecs away. Yeah. And then just look at this formula. What if we are 10 parsecs away? Well, 10 over 10 is 1. What do you raise 10 to get 1? 0. And so basically m minus m is 0. They are the same, right? That makes sense, doesn't it? Try that one. Put that in your SMIPE and poke it. So now we'll see how good you are at logarithms. What's its apparent magnitude? Well, I think little m is going to be big M plus. Right? You guys are like done, yeah. Yes, yeah, yeah. Yep. So big M, absolute magnitude 6.3 plus 5 log. Yeah, you got it.
moves in 4 different ways.
That's attention to detail.
One with a double O, there's one with an E and a W. There's one with a U.
There you go. Yeah.
It's a new story. It has one.
I always try to stay abreast of what's on the back of those boards. There's some words you just can't use in high school, right? Abreast. Yeah, there you go. What? Means what? No, next to you, abreast. You can walk 4 abreast. Yeah, you can't say that either, can you? What does that mean, really? To the high school student. Is everybody good? Have we all gotten 14, 13.8 or something like that?
You should just
This
start
one
speaking
says
that
for a
word
good
into
time to call
the
Mr. Murray.
Yeah.
There's a phone number.
Really? What is it?
5032. Oh, it's Pizza Hut.
Well, I do work at...
It says below it, this is Pizza Hut.
Oh. Call Mr. Murray for a good time. All right.
Take one whole day and call all these numbers.
Yeah, seriously, like after the IB test, you got
It says 5032.
Okay. Most important concept.
Pizza Hut.
And it's Mr. Murray. Maybe I should work at Pizza Hut. Actually, if we have a furlough day, if we have days where we like cut school and I'm not getting paid, I want to get one of those jobs where you're standing dressed as like a slice of pizza next to the road, waving something, right? I just think that's a hard job. And I would just love to have all my students driving by me, right? Here's a day I'm not getting paid. Hey, I'm out there earning money, right?
the little Slater guy. Yeah, he's got to be on drugs because he's always playing on his fake stuff.
See, I could do stuff like that. That would, yeah. Okay. Most important concept. 2 important concepts of the day. The first one is that if we know how bright a star really is and how bright it appears to be, we can figure out the distance to the star. If we know how bright a star really is, look up here, look up here, look up here. If we know how bright a star really is and how bright it appears to be, we can calculate distance. If we know how bright it appears to be, how bright it appears to be and how bright it really is, we can calculate distance, yeah? These are just 2 ways of doing the same thing, right? I like this way better. Okay, anyway, so the second one is HR diagrams. Okay, and they're called HR because they're named after Hertzsprung and Russell. So it's HR or H&R block diagrams, right, if you prefer, right, as we call them. And then Enyar Hertzsprung. So if you're thinking of name for a child, right, don't pass up Enyar, right? It's just one of those names that, you know, it's gone out of vogue, but let's bring it back, right? Henry Norris Russell at Princeton independently did this, right? What they did was they plotted the absolute, or the apparent magnitude, let's back up, the absolute magnitude, how bright the star really is, and plotted it versus temperature. And what you would expect is that as it gets hotter, it gets brighter, yes? Okay? And so this is what it does. Now this graph is deeply wrong in so many ways. Okay? Notice that temperature is plotted backwards. If you did this graph last year, I would laugh at you and write something sarcastic. In fact, Excel I don't think lets you make this graph. I don't think you could make this graph, right? So this is hot, this is cold, right? Here they show it as temperature, but the astronomers do it by spectral type, but it's the same thing. These spectral type O stars are the hottest ones, and Be a Fine Girl, Kiss Me, type M stars are the other type, right? They're the cooler stars. Okay. Now, check out the vertical axis. The vertical axis is actually done correctly, but it looks wrong, doesn't it?